Uh, Myself, Jayashree. I am a full-time PhD scholar of Sigrivan Global University, Odisha. And my topic is on efficient implementation of entity onboarding and authentication in zero trust systems. These are my co-authors. These are my outlines. So first, in the introduction part, about the zero trust architecture, it based on a security model, that is zero trust security model. It is a proactive, dynamic, and real-time security model. Means it allows the security teams to take timely action and mitigate the security risks and prevent further damage. And it also provides the real-time visibility and reporting that enables the security teams to identify and respond to security incidents promptly. The zero trust security model, it assumes that any entity intending to access the enterprise resources would be malicious and should not be trusted by default. The traditional security model that is using or previously used that create a network perimeter and they rely on that. So if any object means identified inside the network perimeter, it is trusted by default. And if any object wants authenticate to the traditional security model, it can use every resource of the network and got access for a long time period. So if it could be malicious that if any malicious object got once authenticated and got long period of time to access the resource. So mitigate these type of challenges, the National Institute of Standard and Technology give the concept of zero trust architecture, which is different from the traditional security architecture. Here is a logical view of zero trust architecture is mentioned in the screen. Here there are two plans. One is data plan and another one is control plan. In data plan, if any user want to use the enterprise resource, then the user need to send the SS request with the user's credentials, means ID, password, or requesting resource and PKI certificate that come to the policy enforcement point of the zero trust architecture. And this point send the user request to the policy decision point. And at the control plan, inside the policy decision point, there is a policy engine that evaluates the access decision on user request to grant or deny the access request of the user. And it takes the decision based on the information provided to the policy engine, and it take decision and send it to the policy enforcement point. And based on that decision, the policy enforcement point allow the user to access the resource or can deny the user to access the resource. So our main component here to authenticate the user for the enterprise resource, we have used the main thing is public key infrastructure. It's provide a framework that manage the digital keys and certificates and secure the communication over the network and also verify the identities of the requesting entities over the network. So some key components of PKI are public and private keys that can be used for the encryption and decryption process. And at the generation of certificate, we can use this. Then the second one is the certificate authority who validate the user's identity, generate and manage the digital certificates of the user. Then third one is the registration authority who is the intermediary between the entities and the certificate authority, and it collects the information about the requesting entity and validate it and send the validated user's information to the certificate authority. But in our proposed work, we have reduced the work of registration authority, and instead of it, we have used the identity and access management system to validate the user's identity. The fourth one is the certificate repository. It stores and manages the digital certificates. And fifth one is the certificate revocation list distribution unit that check the validity, means the issuing date and expiry date of the certificate. Then sixth one is the key management system that generates, stores, and manages the digital keys, means the private and public keys. The main components of PKI is the digital certificate. So it's an electronic document that ensures the authenticity of the entities. And here some the components of digital certificates are the owner's name, means the user name, the validity period, means the issuing date and the expiry date of the certificate, issuing certificate authority, then owner's public key, then digital certificate signature of the certificate authority who signed the certificate by using the private key. Then now come to our proposed work. First, we have generated a self-signed certificate authority using the open source secure socket layer tool. So first, we have generated the private and public key for the certificate authority. Uh, the command to generate the private key is mentioned in the screen that we have used the OpenSSL. And then we have generated a self-signed certificate for the certificate authority that can be valid for 365 days. Then we have generated a certificate for the requesting user through the certificate authority. So first we have generated the private and public key pair for the user using the RSA, means the Ravish Samir Adelman algorithm. Then we have created a certificate signing request for the user, including user's public key and identity information. The command to generate the certificate signing request is mentioned in the screen. Then this CSR is provided to the certificate authority. The certificate authority then checks the user details and publishes the certificate for the requesting user. And this certificate generation for the user thing happened during the user registration of the Zero Trust network. So the network is user registration in Zero Trust network. First, here, if any user means during the user registration, the user need to send the user details with the certificate request to the policy enforcement point. Then the policy enforcement point send the user details, forward the user details to the identity and access management system, that is AMS. And this system validate the user identity and send the validated user identity to the PKI for the certificate generation and store the validated user information in the database for the future reference. Then the PKI design or generate the certificate for the requesting user and send it to the identity and access management system. Then this system send one copy of certificate to the authentication server for the further use and send one copy of the certificate to the policy enforcement point, and the policy enforcement point send the user certificate to the user. Then our final work, we can see here, that is user authentication and authorization using the public key infrastructure in Zero Trust network. So here, if any user intending means that want to access the enterprise resource, then the user need to first send a request that first form to the policy enforcement point. In request, it can be user ID, password, the certificate, and the type of resource the user want to use. Then this request first form to the policy enforcement point of the Zero Trust architecture. Then this point forward the user details to the identity and access management system. Then this system validate the user identity with the data user information that we have previously stored in the database. Then send the validated user certificate to the authentication server. Then the authentication server also validate the user certificate and send the authentication result back to the identity and access management system. Then this system create an authentication token and send it to the policy enforcement point. Then this point send forward the authentication token to the policy decision point. Then inside the policy decision point, as I told, there is a policy engine who take or evaluate the access decision on user details. It takes the access decision and send the create an authorization token on that and send it to the policy enforcement point. Then this point, based on the access decision, allow the user, suppose it is granted, then the policy enforcement point allow the user to access the resource particular resource for a particular period of time and start communication between the user and the resource. And it also monitored the communication between them. And if it found any suspicious thing, then stop the communication between them. So this is our proposed work for the zero trust network. And now in the conclusion part, the zero trust security model that ensures the robust authentication and the requesting entity of means it allows that the requesting entity of the zero trust system that must be authenticated. Here we have authenticate the user using the extra level, that is using the digital certificate that can be used for to validate the user's identity during the authentication process of the zero trust system. First, we have generated here a self-signed certificate. Then we have generated the digital certificate through that certificate authority in the zero trust enterprise systems during the user registration. Then we have performed the authentication by the policy enforcement point of a zero trust system using AMS and that we integrated with the authentication server. And also the extra thing we have added here, the authorization, that we have performed the authorization of the requesting user by using the policy decision system of a zero trust system. So now done. These are my references. Thank you.
Any questions to the other? No, I have one question. Has this been implemented or it is a theoretical proposal only?
No, sir, it is implemented. We have generated both the certificate authority and the certificate also for the use. And implemented in the zero trust system.
That is, how many bit RSA has been used?
Sorry, sir.
No, RSA, is it 1024 we have used for testing or 2048 bit or what is it that has been used?
Oh, RSA. RSA we have used to generate the public and private key.
I see.
Yes. Using that OpenSSL.
Okay, let us thank the speaker. We will go to the next.